In this video, we're going to talk about how to combine like terms. So you're probably asking yourself, what even are like terms and how do I recognize them? Well, the good thing about the way we name definitions and properties in math is that they're really descriptive. So like terms means terms that are like each other. So basically, this just means the expressions have the same exact variables raised to the same exact exponents. So here you can see some examples. 5x and 1.08x are like terms because they have the same variable, x, raised to the same exponent, 1. If you had 5x squared and 1.08x, they would not be like terms. So same variables, same exponents, but the coefficients, or the numbers in front of the variables, can be anything. Let's take a look at our first example adding like terms. In this problem, we have 3x squared plus 5x plus 8x squared. Now, when you're adding like terms, you need to find your like terms. Well, how do we do that? Do you notice any differences between these polynomials? We have 3 terms, right? But they're different. So 3x squared and 8x squared are like terms because they have the same variables raised to the same exponents. Although all 3 terms have x's, only 3x squared and 8x squared have x raised to the same power of 2. So we're going to have 3x squared plus 8x squared plus 5x. And I like rearranging this so that I know which like terms I'm combining. And you could think about it as you're going to keep that like base raised to the same power and just add those coefficients, right? So you really have 3 plus 8 x squareds. And then you just have your plus 5x, right, off in the cut there. So 3 plus 8 is 11. So 3x squared plus 8x squared is 11x squared plus 5x. So when you're adding like terms, you want to look for like terms, combine them by adding the coefficients and keeping the variables and exponents the same. And sometimes you don't have like terms, and that's okay. You just leave those alone and don't combine them to the like terms. In our next example, we have several options for our like terms. So we're going to focus on the 5a squared b and figure out which of the terms that I'm listing underneath it is going to be a like term. So you have 12ab squared, 6a squared, 9a squared b squared, and 7a squared b. Oh, and let's not forget 14b. Go ahead and pause it and see if you can figure out which of these are like terms to 5a squared plus b, or excuse me, 5a squared times b. So taking a look, 12ab squared, that's not right. We're supposed to have a raised to the second power, and then just b to the first. 6a squared is close, but we're missing the b, right? So that's wrong. 9a squared b squared is close, but b is to the second power. 7a squared b, that's looking good. 14b, it's missing the a squared. So even though a lot of these have similarities, they're not the same, right? So we're going to add 5a squared b plus 7a squared b. Now that we know that they're like terms because they have the same variables raised to the same powers, we're just going to have some number a squared b. So we have 5 plus 7. We're going to add those coefficients. 5 plus 7, I just do that in my head or just in my calculator really quickly. That's 12 a squared b. You might want to kind of go old school back to how we learned how to add in elementary school by doing stack and add. It's the same idea, 5a squared b plus 7a squared b, but you might kind of see the 5 plus 7 a little bit easier and you just bring down those variables. But either way, if you're getting 12a squared b, you got it right. So again, adding like terms, you just need to find your like terms, right? Same variables, same exponents, and then just combine those coefficients. And that's all there is to adding like terms. Now let's look at how to subtract polynomials. All we need to do is combine our like terms, and we can think of this as subtracting or adding a negative, and that really depends on how you added and subtracted when you were in elementary school. So we have the problem 5a squared cd cubed minus 2a squared cd cubed. Don't freak out. I know that's a lot of letters, lots of exponents, but as long as they are the same letters raised to the same exponents, they're like terms. So we're going to combine the coefficients 5 minus 2. Again, you can think of this as 5 minus 2 or 5 plus negative 2. Either way, you get 3, and then we keep our variables the same way, right? So 3a squared cd cubed. You can also stack and subtract. I had the stack and add on my brain, but like I said, you can think of it as adding a negative, or we can think about it as just subtraction. To each his own, doesn't really matter. So when we're stacking, it literally means you stack your terms on top of each other. So 5a squared cd cubed stacked on top of minus 2a squared cd cubed. And then you combine, right? 5 minus 2 is 3, a squared cd cubed. So either option gets you the same results. It's just a matter of which one you do correctly more often. Pick that method. I'm going to make you think a little differently on this problem. When we have 10hk to the fourth power, what can we subtract from it that has a coefficient of 27? Pause the video and think about it. Can you figure out what has to go in this red box in order for us to actually be able to combine like terms through subtraction? So there's only one way, right? There is only one answer for this, and that's because we have to have the same variables raised to the same exponents, so it has to be hk to the fourth power. So 10hk to the fourth power minus 27hk to the fourth power is simplified by combining your coefficients. 10 minus 27 is negative 17, and then you just have your hk to the fourth power. Now, hopefully you're feeling like this makes a bit more sense, because literally all you're doing is the addition and subtraction you already mastered in elementary school with the added variables, right? That is the hard part of it. You just can't get bogged down by seeing letters in math, right? Letters in math are not going away now at this point. So really make sure you're identifying like terms, especially when you have a whole bunch of terms in a problem. Find the ones that are like terms, combine them. If they're not like terms, don't combine them. And then you just check your work at the end. So it's the addition and subtraction you know how to do with some fun variables thrown in. We're going to take a look at some mixed problems that have addition and subtraction in them so that you can feel really confident on your skills. So stay tuned for that, and let me know if you have any questions by leaving a comment down below. Okay, we're going to review what we've just learned. So remember, when you're combining like terms, all you do is you find your like terms by looking for terms with the same variables raised to the same exact exponents. And then you just add your coefficients. This is because you can think of subtracting as adding a negative number, right? Or you could just think, okay, I'll add if it says add, and I'll subtract if it says subtract. And that is a personal opinion, and it probably comes back to how you were taught in elementary school. Either way, you'll get the same answer. But if you want to think of subtracting as adding a negative number, here's an example for you. We have x minus 3x, which is the same thing as x plus negative 3x, right? Same exact thing. So remember, if you have just x or any number that or variable that doesn't have a coefficient, there's an understood 1 there. And then we just have 1 plus negative 3 x's. And when we simplify, we find that x minus 3x is just negative 2x. So let's take a look at an example with adding and subtracting in it. We have 6x plus 11y plus 3x minus 5y squared minus 2y. So that's a lot going on. Do not be afraid. Do not freak out. Do not click out. You can do this. You can even pause the video and try this out and then come back and see if you were right. I bet you can do it. Personally, to help me not feel overwhelmed and also not to make careless mistakes, which I've been known to do, is to use color coding. That is a great visual organization tool for me. So I've got 6x, which I see is a like term with 3x. I've got my 11y. The negative 5y squared, did that trick you? That is not a like term there because y is raised to the second power. But it is a like term to negative 2y. Do not forget that negative sign. And then I just used a red heart. Why? Because why not, right? I just need to differentiate between my terms. And now I'm going to group them together. So I have 6x plus 3x. I'm going to group them in parentheses and cross them out as I go. Again, these are pro tips from someone who has made mistakes. Then I have plus 11y minus my 2y, super emphasizing there that you need to subtract. And then you just have negative 5y squared off on its own. And then we have our like terms grouped. So now we know we're going to keep that variable in those like terms and just add the coefficients. So 6x plus 3x gives me 9x. 11y minus 2y gives me plus 9y. And then just your negative 5y squared. If it doesn't have a like term, that's fine. It actually makes it really easy because you don't do anything with it. It just hangs out, right? So let's take a look at one more example. And in this example, I want to see if you can do this all on your own, right? We've had lots of practice. Again, I encourage you to pause the video, get out some paper, a whiteboard, your iPad, whatever, and try the problem out. We have 8y plus 12y plus 17 minus 4y plus 5. You can see I'm identifying my like terms with the variable y raised to the first power. And then I actually have like terms because these don't have variables, so those are called constants, and the 17 and 5 will be combined together. So personally, I like to group in parentheses so that I make sure that I have that visual reminder that those are all the terms being added together. So let's break it down. 8y plus 12y minus 4y is the same thing as 8 plus 12 minus 4y, and then 17 plus 5 is 22. So I'm kind of thinking in my head, 8 plus 12 is 20, 20 minus 4 is 16, and then I've got my y, which is a little cut off there, but that's a y, plus 22. Now, we want to get in the habit of checking our work because it's really important that we have the confidence and the knowledge to verify if our answer is correct. So what I like to think about is going back to the beginning. 8y plus 12y is 20y, minus 4y is 16y. And then I think 17 plus 5 is 22. Am I correct? Yes, woohoo, celebration. And ultimately what would be great is if we can go from that very first line straight to the bottom answer. But if you're clicking on this video, you probably have a little bit of room for improvement, right, on this skill, so you need to show all your work. And there's nothing that says you have to do math in your head. If you always have to do your math on paper and show all of your steps, who cares if you're getting it right? But we think about math as building fluency, and that kind of just means that you're able to do things better, right? You don't have to show all of your work. You're able to do more things in your head because you're more comfortable with the material. So through enough practice, even if you show your work, you probably won't have to show every single step moving forward, and that's why we practice. Plus, if you don't have to show all of your work and spend that extra time, it gives you more time to do more math, and who doesn't want to do that, right? So just to summarize what we've learned in this video, when you add or subtract like terms, first step, find your like terms. Second step, combine them, right? Add the coefficients or subtract the coefficients, and then check your answer, and that's it. So basically, we're just adding and subtracting like we know how to do from elementary school, but we're throwing in some variables for added spice to our life. Thanks for watching. I hope you feel better adding and subtracting like terms. What do you want to see explained in the next video? Comment below to let me know, and I'll calculate later.